Welcome to Metabolism and Bioenergetics Part 1. This tutorial will give an overview and then focus on acetyl CoA. We've been hearing a lot about it, right? Acetyl CoA production is considered like the second stage of catabolism. So let's look a little more closely at this important molecule. Let's get started, right? So let's remember, right, so metabolism is all of the biochemical reactions about the use, production, and storage of energy. And so we've learned anabolism, right? That's the synthetic or reductive, requires energy, right? So endothermic, and we'll learn a new word in this chapter. And then catabolism, that's degradative, or degradation, and it's oxidative, and those produce energy. So we can think exo. Alrighty, so we've gone through the first stage very thoroughly. So you guys are all experts now at hydrolysis, which is great. So the large complex food molecules get broken down into their monomers or simpler molecules. And now in this chapter where we're really going to focus, and we've already talked about the acetyl CoA production for the most part too. Acetyl CoA production, but we really haven't looked closely at this molecule, right? So basically, all roads lead to acetyl CoA. All roads, all paths lead to acetyl CoA, right? Regardless of whether we started with a protein, a carbohydrate, or a fat, our body has a way to get those into acetyl CoA. And why is that? Because this will be an emphasis in this chapter, right? The energy production. Okay, so after we look at acetyl CoA a little more closely, we'll finally study the citric acid cycle and the electron transport chain. Right, because the big deal is we want to get ATP, our energy currency. And we don't get to talk a lot about urea, but so I wanted to just briefly talk about amino acids. Right, amino acids contain nitrogen. And it's very interesting. Our body can store carbon, oxygen, and hydrogen, but our body cannot store nitrogen. So any excess nitrogen atoms from the amino acid that we can't hold in the amino acid pool create ammonia or ammonium ions. And these are toxic. And so there is a metabolic pathway then called the urea cycle, which converts the ammonium ions into urea, which can then be excreted from our kidneys. Oops, let me slide that up. To right through our urine. All right. So this is about the only place I can think to add that information, and I think it's important to our overall understanding of metabolism. So now we'll go ahead and move on to the next page and look at what happens right before the citric acid cycle, right? So right before the citric acid cycle, we need to look at, we've seen how fatty acids can produce acetyl CoA. Let's look a little more closely at what happens with pyruvate and acetyl CoA. Okay, so let's get our next page centered. There we go. Alrighty. So, so here's pyruvate. So by now you probably have the structure in your mind, and if not, it's a good time to get it there. Right? So this is our going to be another example of the thioester formation. Right? So here's our carbonyl carbon and the carboxylic acid, and these will come together, right, to get the water that's typically not shown in the pathways, and we get our thioester. notice in the process we do produce a reduced coenzyme, and this substance here is coenzyme A, right? And so we've already talked about this, but and this will fill in the blanks for the lipids, right? So pyruvate, right, it comes, right, so from glucose, right, so from glucose glycolysis, all right, we produce pyruvate, and we can also produce it from the glycerin from fats. Okay, and so here we have it, but notice that we always just tend to say CoA. All right, so this is the page where we look more closely at exactly what the structure is of CoA, coenzyme A. So, and then once you see this, you'll know why we abbreviate it, right? It's a huge molecule. All right, so this is the entire structure for acetyl CoA. All right, so there are three primary pieces. Well, there's four primary pieces. Here we have the adenosine, right? So there's the adenine, there's our nitrogenous base and our sugar and our phosphates. And then we have the pantothenic acid, the thioamine, and the acetic acid, right? So these four compounds come together to create acetyl CoA, right? So when you see coenzyme A, it's these three molecules. And then when we add the acetyl group. Alrighty, so let's practice classifying those bonds. So take a moment to do that. Right? And so when we look at this bond right here, right, we recognize that as a thioester. So that's the bond that we showed that was formed in the reaction above, right? So C, reaction above. And now if we look closely, the thioamine, how does it connect to the pantothenic acid? What type of bond is that, right? So that is an amide bond, right? Since these aren't proteins and amino acids, we don't call it a peptide bond. We would call it an amide bond. And then the last linkage is right here, right? And we can look at the pantothenic acid, and we notice it was an alcohol, and an alcohol linking to a phosphoric acid, right? So that's a phosphate ester bond. Okay, so there are the three bonds that link together the four compounds to create acetyl CoA, right? So acetyl CoA. Alrighty, so that wraps up our introduction to metabolism and bioenergetics, and now in the future tutorials we'll dig in deeper and look at the citric acid cycle and the electron transport chain. So stay tuned for more information.